All right, we are live. So just a few minutes ago, Tesla dropped a new video of Optimus. This time it's walking around the lab. We probably know why they dropped this, but first of all, they promised that they were going to continue to drop new demos. But secondly, yesterday there was a bombshell announcement or reveal that Figure Robotics has raised $675 million dollars with a host of new partners. We did a show on that yesterday. Today we're going to look at Optimus. We're going to watch the bot walking, and then we're going to review what they showed, how hard it is to walk, and we're going to compare it compared to what the other previous bots, Tesla bots, were able to do. And Scott's going to reveal what is the most important thing to watch out for. So I'm going to go ahead and play this, Scott, and you tell me what it is that we're watching. This is dropped by Tesla Optimus X account, and they showed this video.
Okay, so it's the first time I've seen that one dropped. I saw the one earlier by Elon, which I think was much fuzzier, lower resolution. But we're seeing Optimus not just walking, but walking sort of a path, so a curved path, so we get an idea of how well the robot's able to perform when it has to take a turn. This is one of the things I've been concerned about. It's one thing to show a bot walking in a straight line with a certain velocity, but can it maintain that velocity while having to do turns? These are not really tight turns, but they are turns nonetheless. It seems to be very stable, very confident, maintaining a pretty nice gait. The walking is, you see the full body is in there, a lot of hip rotation, a lot of movement in there, almost kind of sashaying around the lab. And the first thing I did when I saw this was count the steps, and then from the steps try to figure out how many steps per second they're getting, because we know the length of the video, and the video is confirmed to be 1x. The other thing, now there's a slightly higher resolution, it might be easier to be able to count the number of bots that might be in the background. Now, I suspect we're not going to see any different number of bots in the background that we already saw before. From the previous video, we counted up quite a few bots back there, but they were all the Gen 1s. We didn't really see a whole lot of Gen 2s in the background. It's hard to tell now. The other thing to notice is a couple of strategically placed curtains. And I'm not sure if those curtains were put in place when they decided to film this, or were they just always there in place to maybe prevent other people from other departments maybe seeing what's going on, or just a little bit of protection. So it seems to be a pretty big workspace. There seems to be a lot of activity in the background, which we assume are either bots being assembled, maintained, or possibly doing training, because that looked very similar to where we were seeing the training tables before, where the teleoperators were doing various things. So gait looks very nice. It's still not quite full human speed. So based on the numbers, I did a quick calculation this morning. I think I counted 132, but that was like one time. I didn't have enough time to count a second time, but it's around that number. Someone can verify that. And I believe the length of the video is a minute and 18 seconds. So that's 78 seconds right there. And when you calculate that, you're getting about 1.66 steps per second in there. So now you get an idea of how quickly the gait is going. We then have to estimate what's the stride length. And looking at the stride length, it seems like it's a little bit longer than one Optimus foot. Question is, what's one Optimus foot? Is it 10 inches? Is it 12 inches? What is it? It seems to be a little bit more. So trying to be conservative with it and saying that, okay, if one step is about 1 foot, then that whole thing translates into, I think the calculation, I had to bring up my own post because now I'm even forgetting my own numbers there, that I think it was a little bit over a mile per hour, something like that, like 1.1 miles per hour, if you're assuming a step size of about 12 inches. If you think it's a bit more, like 14, then you get closer to like, I think 1.3 miles per hour. And that means you're now getting you're getting a lot closer to where you'd like to be. You'd like to be somewhere around 2.6 miles per hour. So it's like, right at the 50% mark. We'd like to double it. And then we'd say the walking speed is really good enough to be able to use it in the factory for a lot of different operations, because that's about the estimated speed that you have for humans walking in there. Not as fast as 3 miles per hour, about 2.5 is fine. But remember, that's if you're doing, let's say, a distance walk. If you're doing something very short, you never really get up to top speed anyways. So you may be able to go with a slower gait and still be able to do useful work.
Hey Scott, we just got dropping news right now. Milan Kovac just dropped a tweet, so let's take a look at it. He says he's part of the Tesla bot team, of course. He says this is our fastest gate ever at 0.6 miles per second.
Mm-hmm.
Or is that meters per second? Sorry.
I calculated 0.58 meters per second.
Okay.
That's what I
Greater than
calculated.
30.
Yep.
Perfect. Greater than 30% speed boost since our last video in December.
Yes,
And I'll show you
that's
guys
about
what
right.
it looks like.
I think
We've
that one
improved
was
our
about 0.46. Yeah, yep. Okay, good.
we've improved our vestibular system, our foot trajectory, and our ground contact logic, everything you just said. We've upgraded our motion planner and made cuts to the loop latency across the bot. Optimus is more stable, more confident, even during turns. And you wanted to point that out. We also added a slight torso and arms sway. If these challenges speak to you, join us for our amazing controls team.
Okay. First, props to Milan. He's the first one to tell us how fast they really are walking. Okay. I've asked that numerous times. And when showing walking, and I just say, how fast? So now we know, and we know it's halfway. They've officially hit the 50% mark, and it's getting a little bit faster. So, it seems that we have an idea that the stride is probably about a 14-inch stride. Now, there's two ways you can run faster, and this is what our track coach taught us. He said, one way is that you can make your legs move faster, right? Your stride count. But he said that's really hard to do. The best thing is to make your stride longer. So he was always making sure that we get the most out of every stride, lengthen the stride. That's what they're going to do. They're not really going to care about getting it up to 2 strides per second. What they're going to try to do is get slightly longer, and you're going to get that with a slightly better toe off. So now if you get maybe like an 18-inch stride in there, then you're going to be able to bump it up quite a bit. So that's probably where we're going to put a little bit of work. Again, the vestibular is basically mean balance control. So they've got enough confidence that they can now start to do these turns. Walking straight is challenging, okay? It's already challenging. But trying to walk in a curve and do it with confidence, that's a little bit harder. So, and to really do that, they need to have all the arm sway and everything else in there. So that is great information to be able to hear. And again, they seem to have the confidence, the ability to walk. The next thing I really want them to see is to be able to do a pirouette. And and I don't mean the literal pirouette like a ballet dancer, the arms up there and spinning around like that on the toes, but really being able to do a very quick 180. Pick up a box, take a quick step back, and then turn yourself around and head in the other direction. And do that like that. Because when you look at some of these pick and place operations where everyone's thinking of going in warehousing type of applications, most of your time is spent turning around, going the other direction, turning around, coming back. It's not the steps between, it's the steps at the table.
I'm just pausing in here because you said count the bots behind. It looks like quite a number of them are there.
It's hard to tell. Are they bots or are they people? It was so fuzzy.
No, you can see right there. There's two hanging, one right there.
That looks like an old one. That's an old Optimus. So they have maybe a dozen of the old Optimi sitting around. So that's why it's kind of difficult. And I don't care about counting the old ones. I want to count the new ones.
One there. Initially, when Elon first dropped this is what he dropped. It was very, very fuzzy. People were making fun of it. And we thought maybe he did this on purpose because then you can't see all the things in the back. But then, of course, pretty soon,
he probably had a crappy cell phone connection and someone SMS, sent that to him. And usually those are already low resolution. Then he said, oh, looks good. Then he posted it. And then someone had to go back and upload it properly. So if he didn't have a good Wi-Fi connection, I could understand they weren't able to send him a good a good copy of it. And then they probably went through and scrubbed to make sure there's nothing in the background they didn't want to see. And again, I want to count the number of bots, but I don't think we're getting any new information because it looks like the same number of bots we counted before, mainly Gen 1. But if someone, and unfortunately, I'm on the road right now, so I can't go in and use any better forensics, like a bigger screen or something like that to go in there and count it. I'm hoping other people are doing it. I'm sure everyone else is considering doing the same thing. So, any information you can find. I don't think we'll see anything up close on the bot because it is well covered now. The previous one, it was not wearing its armor. Now it is. So we know what the speed is. And now if they've got another 30% over the 30%, that's good. So that one there, looked kind of slow. And I almost thought it was maybe slower than the other version we had seen. And probably it was slower because they had changed the algorithm. So they had one that was already walking at a
Yeah.
fairly good clip, but they knew to move forward, we have to change the algorithm. They changed it, and it was like, nah, it's okay. And now we've seen, in what was that, 2 weeks ago, they've been able to bump it up again to get up
Yeah.
to that 50%. Okay.
So, Scott, do you believe then? Okay, so we just watched from Teslanomics a beautiful rendition of all the different bots that they've been dropping regularly of the evolution of this Tesla bot. Do you think at one point they said that the lower extremities was not yet neural net controlled? Do you
Yes,
think that based on what you heard now and the way it's looking, it's now neural net? That's why that the latest you saw
probably.
without the armor looked like it was clumsy, but this one here looks like it's now much more,
Right, right.
more.
Because I
Yeah,
think, and you kind of brought that up when we saw the under armored one, okay,
yeah,
or the unarmored one, that you thought, oh, maybe they are using neural nets now for the walking, because it did look a little bit improved, just slow. And of course, when you roll out the new algorithm, it's going to be slow at first until you can tune it.
this one. Yeah,
And so I said, yeah, Herbert, you're probably right there, that there's a tighter integration with all the walking and everything else. And now when you look at it, it seems to be a very good control system where the whole thing is probably nothing but nets.
yeah. Okay, so let's watch a few more things here. Let's take a look at this clip from AI Gen 2. So AI Gen 2 happened in 2022, and you wanted to show back then in 2022, they'd already been thinking about this, and you
Yes.
could tell us what you're hearing here.
So now
Right. So what they
humans
were
do
doing
all
is
of
they were
this
showing a lot of the locomotion
but as
planning that they were going to
engineers
be
or
doing.
roboticists, we have to think about these problems. And therefore, I'm going to show you how we address them in our locomotion planning and control stack.
And in this
So we
locomotion
start with
planning, the
locomotion
movement that you
planning
see is going to be very
and
similar
our
to what we're seeing in
representation of the
reality now.
bot. That means a model of the robot's
Part of the
kinematics,
locomotion planning
dynamics, and the car-side
simulations that they did
topologies.
was
And
to
using that
understand the
model and a
torque
desired
requirements
path,
of each joint that they would then use to figure out what the actuator's torques needed to be. So you have to look at all the different possibilities, walking, stooping, walking in a turn, everything else. And they showed some early simulations of doing that, where you could see an Optimus kind of walking along, looking kind of confident with the entire arm sway, the whole body, everything else, to get an idea what they are. And now, so exactly, this one here, you
Okay.
begin to see this.
I don't know if you can hear, but when I press play, you're gonna hear them talking. Should
Okay,
we let them talk first, and then you
okay,
can reply to it?
here we see footsteps being planned over a planning horizon, following the desired path. And we start from this and add then foot trajectories that connect these footsteps using toe off and heel stride, just as humans do. And this gives us a larger stride and less knee bend for higher efficiency of the system. The last stage is then finding a center of mass trajectory, which gives us a dynamically feasible motion of the entire system to keep balance. As we all know, plans are good, but we also have to realize them in reality. Let's see how we can do this.
okay. So that's an example of where they were already saying Optimus
Felix.
doesn't just walk straight;
Hello,
it has to take a
everyone.
turn.
My name is Anand, and I'm going to talk to you about controls.
Okay.
So
Did
let's
you want to see
take the
more?
motion plan
No,
that Felix
that's
just talked
fine. So
about and put it in
so
the
they
real
already
world on
had a plan in place. They've already been simulating these different activities, but it's pretty easy to do these things in a simulation. To go through to see what's going to be there. It's something else to then build the hardware to be able to deal in the real physical world. And they seem to be getting closer and closer to that. So when I saw that Optimus was making the turn, I thought back to that. It's like, yep, there we go. That's what I've been wanting to see. And I've been mentioning that recently. And that's why I'm glad to see this. I don't know if they've necessarily been paying attention to me, but I've been wondering, when are we going to start seeing them doing a little bit more? Now, yes, Boston Dynamics has already shown their bot going around being able to do turns and everything else, but Boston Dynamics is hydraulically actuated. It's very different. We're now talking about the bots that are using electrical actuation along there, and it's nice to be able to see it taking different kind of pathways. What we don't know is exactly how they came up with this pathway, whether they just let Optimus roam about and just kind of take some random directions or whatever it felt like, or whether they may have given it, let's say, some waypoints on the floor to say that we want you to go, to these locations, and it just sort of decides to go here to there and something else, and just do these very smooth trajectories. So I don't think it's necessarily, telerobotically controlled, but they probably somehow gave it some target locations and then went ahead and planned it. And then it's going ahead and executing that. So the fact that we're seeing it untethered, walking for well over a minute, I'm sure they are already doing the knockover test, where they'll be going up and pushing it and pressing it and trying to get it to fall over. They're probably not going to show that. And I think a lot of the other bot companies also are kind of at the stage that they don't really want to show humans going up and trying to knock it over. But there will be these testing phases they have to do to check the balance. So we're going to see more and more of it. And some of them will probably be more challenging environments as well to see how confident it really is. But it doesn't have to operate outdoors yet. So flat environments are fine for now. Eventually, yes, you can come up with a less structured environment to see how it behaves on that. And I'm sure they're already doing testing like that in the back rooms.
So what do you think, Scott? We've seen this evolve from that original Bumblebee to this, to this. The Gen 2 was revealed in December, which is literally just 2 months ago, 2 and maybe 3 months ago now. December, January, February, 2 months ago. And then now we see this, you can see the difference. This is right here, right? So this one here in the middle, that's December. Yes. And then this one is February. It doesn't look like there's any changes at all to the form factor.
Whose post was that? Because did someone post that?
Which one?
Yes. The source for this. Yes.
Yeah, this person here did it. We should give them credit for it. Optimus Gen 2 walking faster, Henteta did it.
Okay. That's great. Yeah. Great. Good. So they went through and they did the step counting, running them all at the same speed. So we get an idea of sort of the improvement. So we're going to, from 6 to 8. So that's about a 25% improvement there.
Had to run it long enough directly from Milan. We already got it from Milan. It's a 30% speed boost since our last video in December.
Yep.
But look at all the other things they did. They improved all of this in just 2 months. I mean, so that seems like significant, fast improvements. 2 months. They did all this: vestibular, ground contract, motion planning, loop latency. It's more stable, more confident. Even added the slight torso and arm sway. Remember when we were talking about that? You can actually see the torso, the hips, like, the hips going up and down as you're moving. And the question for me is it neural net? And I believe it sure looks like it's all neural net at this point.
It has to all be integrated in. You need to make sure they're all aware of what they're doing or attempting to do to get that sway right. Otherwise, it'll be kind of counter and you could lose balance. So it's got to have full awareness of what everything's going on. And the best thing is to integrate it all together.
Yeah, that lab looks like everybody's working really hard. There's all these bots hanging around. They must have at least 20 at this point.
And what's behind the curtain?
Yeah, what's behind the curtain? Tell me.
That's I don't know. What's behind the curtain is more area, is a lot more space. I mean, so you see they have a very large area that they can work with.
What's behind the curtain?
What's behind the curtain? Yeah.
Last time we saw
the last frame. Let's go to the very last shot. What do we see in the very last shot?
This is the last shot.
No, one more step. One more frame. One more frame. One right there.
Yeah.
Optimus in front of the heart.
Yeah, sure. That's old. That's just the way it happened.
Yeah.
I don't think that means anything. Yeah. How does this compare to the other bots that we've been seeing in terms of walking and form factor?
This is the one that looks the most human-like, both in form factor and in the movement that we're seeing, the walking confidence.
Somebody said, "What's in the box?" That's a recycling bin. Those are lockers. Those are standard stuff. What's the box? That one? No, that's a charging. It looks like a charging. No,
could be.
Yeah, that's a computer. What box is he talking about?
And this seems to be also their motion capture area. So what's up on a lot of those booms is capturing the movement, because the last one we saw where everything was taken off, the Optimus was fitted with a lot of these tracking balls.
There's that
so
box.
That they were able to, with a camera system, really be able to capture the movement and compare the movement from predicted. So you always have a planned trajectory where you're trying to forecast what the actual forces are going to be on the bot, so you can kind of predict exactly what you have to do. And then you want to measure that to see how good your prediction is. And then you begin to get an idea of what you have to do to either refine your physics model or what most engineers will call the fudge factor. Because a lot of times you'll have this theory, go along and everything will be really close to theory, but it's a little bit off a little bit. And then you just have to come up with some sort of factor or something that makes it actually match reality. And then it becomes a bit more empirical. And so, either that's going on or they're really trying to figure out what you have to do to change some of your weights, some of the gains that you have in your control system to match it. And that's probably what they were doing previously. In this case, they're probably not, because I don't see any track balls on it.
We just lost you, Scott. We can't hear you now.
You probably will in a second, because
I can hear
Dr.
you now.
Know-It-All
Yep.
is on the other line. That's why.
Ignore. So, Scott, I've got a question for you.
Yes.
So we're watching this bot walk around, right?
Yep.
Has it been programmed? Was it told to walk around in a circle? Is it just thinking on its own?
I would think they gave it some goals. So that's what I was sort of saying, is that they didn't heuristically tell it how to take the steps. They probably just said, okay, go from A to B. The problem is that when it goes from A to B, it's just probably going to walk a straight line. And that's not very interesting. So what they probably said is, okay, we're going to give you a bunch of waypoints, just like when you drive your car. It's like, I want you to drive here, and then here, then here, then here, then here. And so it probably knows that that's the trajectory or the path that it would like to follow. And it's just making a smooth path between them. It's hard to see any waypoint. I mean, one way you get the waypoint is the robot would walk there and stop and then turn and move in the other direction. Instead, they've made like a nice spline out of that somehow and just said, follow this trajectory. That's it. And then it's doing the walking based on that, planning its steps, knowing where it wants to be.
Okay.
And eventually it would be nice to literally make a track on the ground and say, okay, just walk this, just see how well you can walk this and navigate it. So that means the vision system is going to have to see where it is. That should be pretty easy in some ways. It's pretty easy. The problem with that is you got to keep on painting a different circle on the ground, right? If you do it virtually, you get basically the same impact.
So you've been saying this before, right? They're trying to get their gate to be faster. What is the speed they need to have before it's useful?
1.2.
So double
1.2
this,
meters per second. 1.2, which is about
3
2.5 miles per hour.
Okay.
So you need to double the speed.
Yeah. But some people say you don't really need that, because many of the pick and place roles, you don't need to be walking this fast.
If you're standing still and if you only have to take 2 steps from one location to the other, that's fine. So some of those pick and pack, you're right, it's just a few steps. But what might be happening in those pick and packs is how quickly you can rotate 90 degrees or 180 degrees. So if you've got to do a shuffle step to change your direction, if it's going to be like, trying to move the Titanic from one position to another, then that's where you're going to lose your cycle time. And we've seen some of these examples of the bots that are taking a tote off of a shelf, bringing it over to conveyor and dropping it down there. And all the time is being lost on turning the 180. Once they get it, they're trying to back out of the situation. And once they backed out and turn around, then they can walk, and they can walk straight confidently and quickly, but then they lose all their time in the turnaround. So that's the next thing I want to see, is how quickly this can literally turn on a dime. Go over to that table, pick up a box, and then turn around and come back to me. And I want to see that it's able to do that turnaround really quickly without taking 10 shuffle steps to do it. So 1.2 will be the required speed unloaded. And then 1 meter per second when it's loaded. So if it's carrying something that's heavy, then 1 meter per second will be fine. And then that there is what you would be good enough for factory work. You don't have to be 3 miles per hour. So the 1.2 meters per second is about 2.5 miles per hour.
Mm-hmm. So what about the turning radius of this? It's taking wide turns, so you really can't
It's taking a wide turn, but that's fine. And it'll get more and more narrow. So what I'd like to see it do is kind of do a helix in and in and in, see how tight it can do. But that's okay. And that's okay. You're going to start somewhere, and we're going to see a little bit more. But it's the first time we've really seen a non-linear path.
Okay, well, let's just update folks. So basically what happened today is Tesla dropped a new video. They basically showed Optimus now walking. So we've been playing that video of Tesla bot walking around. And then Milan Kovac, who is part of the team, says that it's now 30% speed boost since their last video just 2 months ago. And they improved vestibular, foot trajectory, ground contact logic, motion planning, loop latency. It's more stable, more confident, even during turns. We also added a slight torso and arms sway. So they've been working on this. It sure looks like it's now neural net. You can see the speed difference here between the, an older version in 2023 to the, 7 months later, they showed Gen 2, and it's still fairly slow. Now it's walking faster and faster in just 2 months later.
Mm-hmm.
And what we're seeing is one speed. So we got here Arnand Swaminathan. He's also a part of the Tesla AI robots team, and he says everything is at one speed. And then you're saying that it's important to walk fast, but more importantly, it's the ability to do turns. That's what needs to be seen. We need to be watching them to do that. But the more stable you are, the more likely that you can do this,
Yep.
right? So,
Yep.
Yeah, okay. I think that's great. So thank you so much, Scott. Appreciate you jumping on with me. This is kind of new demo. We want to keep following this. They dropped this video today because yesterday figures showed that they're now raising $675 million. This is one of the competitors to Tesla bot with a slew of partners: NVIDIA, OpenAI, Microsoft, Amazon, Bezos, LG, a number of other partners there. So good progress. Thank you so much, Scott. Thanks, everybody.
Yeah, thank you, Herbert.
Bye-bye.